Hey Jalen, this is 7-3. I started and then I thought, oh shoot, we got to record for Jalen. So, angle similarity is what we're doing for this section, and two A's because we're talking about two angles, okay? Now, a triangle has three angles actually, but I'm going to show you why we only have to focus on really two angles, okay? So here's the deal. Let's go to this diagram right here, and we are trying to prove that those two triangles are similar to each other, okay? Which means same shape but different size, right? Okay? And we talked about yesterday about how, like, if this side, let's say this side is 10 and this side is 5, right? That would mean that our scale factor is 1/2, yeah? Because we're making him half as large as what he was before, right? So that means, let's say that this angle is 80 degrees. Does that mean that this angle is 40 degrees? No. The angles are not split in half, only the side lengths are. So the angles stay exactly the same, all right? So I'm going to erase all that, and let's keep our 80, and we know that that's 80, and we know that this is 80. Okay, now I'm going to make up some other numbers. Let's say that this is 50, and this is also 50, right? I only know those two angles, and that's all that I know, right? But I can easily figure out what this third one is, right? 80 and 50 together is 130, and they all have to add up to 180. So what's the third one? The third one is also 50, right? Okay, this is supposed to be, it kind of looks like an isosceles triangle maybe, but not really. Anyway, whatever.
No, it's fine.
Whatever. So, but then this is also 50, right? So really the way that this boils down, and the reason why they call it just angle similarity, is because we don't need to know the third one. The third one has to match, right? If these two match these two, the third ones have to match by default, right? That just makes sense, okay? So there's no way around it, all right? Also over here, they have this diagram where they have one triangle inside of the other one, and they do have two angles matching. They have this angle matching this one, but then they have this angle right here for the small triangle is matching that same angle for the big triangle. Does that make sense? So like angle B is the same as angle E prime. Does that make sense? Okay, so we do have two angles matching two angles, right? Like that small one is inside of the other one, so those two angles are matching. So by default, we know that this angle right here has to match this angle right here. Like that has to happen. And so because of that, those are similar triangles. Okay, now Luke asked me this morning, this was a kind of a good question. He said, this and this, are those two lines parallel? Do they have to be parallel? If these two, they say that are the same, right? Like this is my transversal. Do you know what those two angles are called? Corresponding, right? They're in the same corner of the intersection, right? They're in like the south corner, I guess, of the intersection. And because those two are the same measure, those two lines have to be parallel. So that's kind of interesting. Yeah, so you were right. Okay, so let's go down and answer some questions. A, B, C, and D. All they're asking is saying whether or not these triangles are similar given the information that they give to us, okay? It looks like some of these might be similar, right? But we'll see if they are. So if they are, we write a similarity statement, okay? Again, that's like this guy is similar to this guy. That's what they're asking for a similarity statement, okay? And then explain your reasoning, whatever. Okay, A. We want to know if those two triangles are similar to each other, okay? So I see the 57s are matching, but the 48 and the 75 are not matching. So does that mean they're not similar? Not technically. Let's look and see what this third angle is right here. So 48 and 57 is 105 if I add them together. And if I subtract that from 180, that is, hey, 75. So if I add these together and subtract from 180, this one will have to be 48, right? Yeah? So are those triangles similar? Yeah. The angles that they gave to me were not the same, but the third one's like it's just rotated around the other direction. So yes, these guys are similar, and we have to write a similarity statement. So this guy is similar to this guy. We're going to go triangle something, and let's, whatever order you want to go in. What do you want to say? JKL, sure, JKL, and J goes with Q, so Q would have to go first, right? K goes with P, and then M is the last one. So if we go in that order, we have to go in that order, right? Okay, the first one doesn't have to be JKL. You could go LKJ if you wanted to, but then the second one has to correspond to that, right? Okay, B. They don't have anything labeled except we know that this line is parallel to this line. That's all that we know. But what are some things that we know? Angel says this angle has to be the same as this one because they are vertical angles. Do you remember that?
Yeah.
Okay, so those are the same measure. So those angles match up, right? What's some other things that we know?
Well,
We haven't talked about those parallel lines yet. It looks like he might be.
what's it called
Okay,
when-
this guy's a transversal, right? Let's talk about him, okay? What about like this angle and this one? Those are alternate interior, opposite interior, right? Okay, so are they the same? They're congruent to each other. If they're alternate interior, they're congruent. Okay, now we really have two angles matching two other angles, so we have it right now. Like he's okay, but if we look at the other one being a transversal also, do we have alternate interior angles there? This guy matches this guy, right? So now we have all three angles matching, right? So what's that mean? Yes, they're similar. Okay, let's make our similarity statement. Am I going too fast? Are we doing okay? Triangle. Let me get rid of all my goop up here. Triangle, what do you want to call the first one? SRX, sure. SRX is the same as triangle SWT. There we go. Okay, so those are similar. Yeah, happy with that? If the angles match up, they have to be the same shape. They don't have to be the same size, but similar is not same size, right? All right, C. Let's check him out. We have 121. I don't know if you can see it's pointing to that angle right there, and 32 is pointing to this one. Okay, let's figure out what the third one is. Okay, so if I add those two together, 121 and 32 is 153. Okay, to find the third one, subtract from 180, and that is 27 degrees, right? Okay, so we have 32 on this one, 29 on this one. This will be 119. Same shape? Nah. The angles are not the same, so he's going to be slightly different shape. The angles have to be completely exactly the same in order to be the same shape. So this is not similar. I'm going to do like not similar like that. Not going to work, right? If one of the angles is off, the whole thing messes up, right? Okay, now D. They don't give you very much information on D. Let's see if we can figure this out. So we do know that this angle right here is 90 and this angle is 90. Okay, so those at least match each other. So we have one angle matching. Perfect.
Those two are the same, aren't they? The U and T, because they're parallel.
Okay, so she says this angle and this angle are the same. They're not parallel, but what type of triangle is this? Besides being a right triangle, what? He's isosceles, right? So because these two are the same, right? Like those tick marks tell me that those are the same, which means that the angles that are opposite, right? Remember doing that crisscross? Those two angles have to match.
Oh, yeah.
Now, not only do those angles match, but if this is a 90-degree angle, what are each of these?
45.
Those are going to be 45s, right? So those have to be 45s as well. Does that make sense? Okay, if it's an isosceles triangle, the angles opposite have to be the same. Okay, now look at the small one though. These guys match each other as well. So that means this angle is the same as this one. But if this is 90, then these are each 45, right? So, similar? Yeah, similar triangles. Yes. This guy is similar to this guy. Okay, am I going too fast? Are we doing okay? This is making sense? Okay. Evan, are we doing all right? Yeah. Okay. Okay, so similarity statement. Let's write this guy out. Okay, GEF is how you did, right? So you went top corner right. Okay, I'm going to be the devil's advocate, and I am going to go TSU instead of UST. Now, the non-stupid thing to do would go UST, right? If we're going GEF, like this order, we should go this way, right? But can I get away with doing TSU? Because this is an isosceles triangle, like technically this guy is the same as this one because they're both 45, so it doesn't really matter, right? So I could go TSU instead, right? And that's totally legal. Okay, happy with that? All right, let's do some, these are harder on the back side. So example 2, we're going to get to a little bit harder. 3 examples, actually the bottom one's really easy, but the next 2 are a little bit harder. We're going to be paying attention to, how many triangles are right here, by the way?
1, 2, 3.
3 technically. Do you see all 3 of them? Yeah. Okay, now we are only going to be referring to this medium-sized one, okay? I'm going to redraw him down here. Okay, this is the medium-sized one. He is NML, and this is a 90-degree angle, right? Okay, and then I'm going to redraw this small one, but I'm going to blow him up a little bit. Okay, I'm going to redraw him down here, and this is MNO. Okay, is there anything we know about that small one?
It has a right angle.
It has a right angle, right? It's not written there, but we know if that left side is a 90-degree angle, we know that we can put him right there also, right? Okay, so we're looking at two right triangles, okay? So how many angles do we need to have in order to say that they're similar? Two. We already have one, right? Okay, so here's the instructions. They give us an A, B, C, D, and they say they do this on the ACT a lot, and it's really confusing for people because they say, which of the following would not be sufficient? Anytime they say not, like especially on the ACT when you're doing that, circle that word or underline that word or do something because you're looking for which one does not work, right? I know a lot of times I go through the answers and I'm like, oh, that one works. Circle it and move on to the next one because you're trying to go as fast as you can, but you're looking for which one does not work. So be careful. So this one, we're trying to prove that they're similar. So A says if angle LMN, if they tell me that LMN, which is this angle right here, is congruent to MON. So they're saying that this angle matches this one. Is that enough now to say that those two triangles are the same? Because we have two angles and we have two angles, right? So that one does work, all right? So I'm going to check him off. We know that A is not the answer because it does work, right? So check B. It says LNM, which is this angle here, matches MNO, which is this angle here. Is that enough information to tell me that those are similar? That only gives me two. We already knew that they were 90s, right? We already knew they were the same, but that still only gives me one angle, right? So I'm guessing that B is going to be the right answer, but let's check back through and see what we've got. Okay, so B I think is the correct answer. Let's see. MLN, they say that this is 28 degrees, and they say OMN is 28 degrees. Okay, is that enough information to tell me that those are similar? Yes, because I have an angle here, that's two angles, and two angles. We're good. So that one works, which means it's not the answer, right? Because we're looking for the one that's not. And LMN, let's get rid of these guys now.
Can we just say it's B and move on?
Can we just say, I know, right? That's what you would normally do. LMN, they say is 52 degrees, and they're saying that this one's 52 degrees. Is that enough to say that they're similar, right? Because we have two angles. Okay, so B is the correct answer. B is the correct answer because it's the wrong answer, right? Yeah, okay.
So much sense.
I know, right? Okay, so there's B. All right, let's move on down below here, and here's what I want to do. Example 3. How many triangles are here?
1, 3.
Is there 3?
Yeah.
No.
What?
No.
Oh,
No.
This is not a triangle right here, right? Gotcha. Right? That's not a triangle. That's a trapezoid technically, yes. So we only have 2 triangles. We're gonna draw out those 2 triangles. The first one is gonna be this one, and I separate these out when I do these problems, and I'll show you why here in a second. So I'm gonna separate him out, and then the big overall one, I'm going to separate him out also. So I'm gonna put him over here, and I'm gonna make him bigger. Okay, so my big one, my small one. There we go. All right, let's label some dimensions here. This is why I separate these out. Let's label some dimensions here. So the green one, or my small one, what's his bottom side called? Y, right? Okay. What about his left side over here? How big is that? 3. Okay. What about the right side? What's that labeled as? X. Okay. This guy over here. What is the bottom side of the big one?
3 plus y. Y plus 3.
Okay, so things that I've heard before that people get tripped on, and this is why I draw them out. People try to use 3. 3 is only from here to here. Then they try to use 3y. You're not multiplying the 3 and the y together. It's y plus 3 or 3 plus y. I don't care how you write it. I'm going to write it as y plus 3. Okay, so that's why I write him out as a big shape, like the whole bottom side, y plus 3. Okay, how long is this side? 5. How long is this other side? 3.5. Now, it tells me that those are similar, okay? Oh, no, it doesn't tell me that. Oh,
Yeah.
it doesn't tell me that those are similar. Oh, are they similar?
Sure.
How's come?
Because
We have this angle matches for both of them because they're sharing that angle. But if these are parallel, right, we have like this angle matching this one because they're corresponding,
Yeah, so it's
and this
similar.
angle matching this one. So they are similar triangles, right? So we have that, and now we can set up proportions with the sides. So we have the sides labeled here. Let's solve for maybe x first. So we'll do x here, and then let's solve for y. Okay? So we've got our x. X is right here. We've got to do something over something equals something over something. What would you like to do? Let's start with x. X over what? 3.5 equals
Oh, you could do no.
Y
Three
plus
over
3.
five.
It'd be y plus 3 over
3 over 5.
yeah.
so we don't want to solve for x's and y's at the same time, so we're going to use the things that don't have x's and y's, like 3 and 5.
So yeah.
So we're going to do 3 over 5. Yeah?
Okay.
Yeah? Okay, and then we cross multiply.
Yeah.
Okay. So x times 5 is 5x, right? 3.5 times 3. Okay, 3 times 3 is 9. What's 0.5 times 3? 1.5, 15, right? Move the decimal. So 9 and 1.5 is 10.5. Okay, don't use a calculator.
Too late.
Don't use a calculator for this part. Don't use a calculator for this part.
I definitely could.
You definitely don't need to. What's 10.5 divided by 5?
That's why I have Jalen.
2.1.
Cool.
Okay, exercise your brain. All right, y. All right, we need some y's going on here. Proportion again. What do we got? We got to use y. Y over what?
Y over Y.
Y over 3. No.
Yeah.
Y over 3.
Yes.
Y over y plus 3, right? Equals 3 over, we could use 3 over 5 again. We technically could use 2.1 over 3.5, but why would we do that if we have whole numbers, right? That sounds silly. Anyway, but we could. So now we cross multiply. Y times 5, 5y, equals 3 times y plus 3, 3y plus 9. Okay, then minus 3y, so 2y equals 9, and y is divided by 2, 4.5. Okay, now we can finally answer the question, because we haven't even answered the question yet. They want to know what BE is, okay? So looking at the diagram, BE is just the same length as x, so BE is 2.1. So that's what BE is. AD
4.5.
is, now AD is going from here all the way over.
It's 7.5.
7.5, because we have to add the 4.5 to the 3, right? So 7.5. That's what AD is. Woo!
Cool.
Craziness. Okay. All right. This is the like stereotypical similar triangle thing that they will have you do on standardized testing, and the thing that you see all the time, like the tree is casting a shadow of blah blah blah, and the man is casting a shadow of blah blah blah. How tall is the tree? Yeah, that's exactly what this is. So we have a person, and I'm going to tell you, if you don't learn anything else today, learn this. Ready? This is my huge pet peeve, and it drives me bananas. 5 foot 3 inches. I have people that screw this up all the time, like adults that don't know the difference between this. Okay, so learn the difference. 5 foot 3 inches is not the same thing as 5.3 feet, because inches is not out of 10, right? If it was out of 10, it would be 5.3, right? But if I'm going to convert 5 foot 3 inches to feet, I do 5 and 3 out of 12. What's 3 over 12? A fourth. What's a fourth as a decimal? 5.25 feet, okay? Drives me crazy. People say 5.3 all the time, okay? So that's the reason why in this diagram, there's 5.25 feet is how tall the person is, right? Okay, now, same thing goes with, I'm gonna step on my soapbox here for just a second. And same thing goes with like babies. So I have a baby born that's 8 pounds, 8 ounces. And I cannot tell you how many times people announce that their baby is 8.8 pounds. That is wrong. How many ounces are in a pound? 16. So this is 8 and 8 over 16, which is 8.5. There's a difference between these two numbers.
Yeah, what if your baby was like 8 pounds, 15 ounces?
I know, right? So 8 pounds, 15 ounces, they would say is 8.15, which is like just slightly over 8. But 8 pounds, 15 ounces is almost 9 pounds, right?
Yeah.
Versus 8.15 is like just slightly over 8. Drives me crazy. Ounces are in 16s. Feet or inches are in 12s. Our counting system is in 10s. They are not like standard across the board. You can't just move the decimal. Doesn't work that way. Drives me crazy.
Can't we just
Ah.
change
Can't
to
we
the
just
metric
use the
system?
metric?
I know, right? Like where they it's just all the same, right?
Yeah,
Drives
we
me
have
crazy.
started debates here.
All right, so we have a roller coaster here, and we don't know the height of the roller coaster, so we call him X, okay? And the bottom and the shadow of the roller coaster is 40 feet, okay? Now, we assume that this is a 90-degree angle that we're measuring straight up, because otherwise this doesn't work, okay? And we're assuming that our person is standing vertical and not slanted and slumped over, so that's a 90-degree angle also, making two similar triangles. The shadow is 3 feet. Our person is 5.25 feet tall. Okay, and we just cross multiply, divide, and do all that good stuff. So let's set up our proportion and cross multiply. What do you want to do? What over what? 40 over 3, sure, equals?
X over 2. 5.
Yep, x over 5.25. Don't use the calculator. Stop. Don't use the calculator.
Libby.
3x
I want to.
equals, no, 40 times 5.25. Okay, what's 40 times 5?
200.
200. Okay, 0.25 is a fourth, right? What's 40 times 0.25?
210.
So,
At this point, it's just
210.
calculator.
No, because you know what? This morning, Kyle typed it in, and I
Oh,
said,
but
"What's
Kyle's
40
slow.
times 5.25?" And he goes 201, and I'm like, "You're wrong." Yeah, it was. Yeah, it was. I said, "My brain tells me it is not, and my brain beat your calculator." So,
And X equals
There you go.
70.
x equals 70. So, it is 70 feet tall. Is the dimensions of that roller coaster. Roller coaster. Okay? All right, on practice. Do all of them. Practice, do all of them. I'll cut the backside down. Just a touch. Practice, do all. Skills practice, do evens. Yeah. Yeah. Okay? There we go. Practice all, skills, practice evens. There you go. Okay? Happy with that? Bye, Jalen.
Bye, Jalen.